Okay. This is the Cilium Maintainers Track session. Another standing room only audience. This is great to see. I think this is about my 20th KubeCon, and probably about my 10th as a Cilium maintainer, and it's always great to see all the excitement and interest in Cilium. So how many people here are using Cilium right now? Okay. Pretty impressive. That's great to see. And all the people with your hands down, I think by the end of this session, you'll understand why everyone around you has their hands up. So let's jump into it. So in case you aren't familiar with Cilium, Cilium began as a CNI, a networking plugin for Kubernetes. And it was built around eBPF as the underlying technology powering all of it. Since then, it's expanded to encompass cloud-native networking, observability through Hubble, and security with Tetragon. And the core thing about Cilium is that all of this is powered by the kernel technology eBPF. On the networking side, it's expanded from just simple flat layer 3 networking as a CNI to including things like cluster mesh, super popular right now with everybody running tens, hundreds, or even thousands of clusters, egress gateway, kube proxy replacement, BGP, gateway API, all these fun things from layer 2 all the way to layer 7. On the observability and security side, people love Hubble. It provides a service map that allows you to view and debug all of your network traffic, and it's probably one of people's top favorite feature about Cilium once they dive into it. And then on the security side, the other top reasons I see people adopting Cilium is around transparent encryption of network traffic for compliance and security reasons, and also for network policy. People are using network policy to secure the Kubernetes clusters because we know security is becoming a really hot topic right now in cloud native. So with that introduction out of the way, I'd like to give a little shout out to Cilium. It's now become the most starred eBPF-based project on GitHub. So I think that's a really exciting milestone for the community in the past 10 years. Beyond that, the CNCF at last KubeCon introduced the Cilium Project Journey Report. It dives into a lot of the things that are happening around Cilium, including the growth of contributing people and companies, and it's really amazing to see Cilium as the third fastest growing project in the whole CNCF ecosystem out of over 200 projects. On top of that, people are actually putting it in production. You saw the hands raised here, but in the most recent CNCF Tech User Radar on multi-cluster management from end users in the CNCF ecosystem, Cilium was rated as the most mature and the most useful solution for multi-cluster management. I know of what I've seen so far at KubeCon, this has become a really hot topic. So if you haven't yet, you should probably check out Cluster Mesh too. And a couple quick updates from Cilium 1.17. On the networking and service mesh side, Cilium now supports quality of service for guaranteed burstable or best effort for network traffic. It has now support for the multi-cluster services API for global services in cluster mesh, another hot topic. I would definitely check out the talk from CiliumCon yesterday. And it now supports Gateway API 1.2. So a lot of updates around networking. On the security side, as I said, network policy is one of the top features in Cilium, and the performance of that has really increased in the latest release, allowing you to also prioritize critical network policies and do network policy validation. And then on the day 2 operations and scale, I've talked to lots of end users around the cloud-native ecosystem. I know people that are running Cilium in clusters with thousands of nodes, as you'll hear later from Google, or also across thousands of clusters too. So there's many new metrics around BGP, network connections to help it easier to manage Cilium at day 2, being able to rate limiter these monitoring events, and including better scale testing too. So that's a quick update of what the project is, what we've been doing in the past 6 months since the last KubeCon. And with that, I'd like to hand it over to Amir to talk about how they're using Cilium at DB Schenker to power containers.
Hello, my name is Amir Kheirkhahan. I'm platform engineer at DB Schenker. and I'm responsible for development and maintenance of reliable and secure cloud platform solutions. And short about the Schenker, it is one of the world's leading logistics service providers, and it offers mainly 4 transportation services: land transport, which we are part of it, ocean freight, air freight, and contract logistic. And we do not only deploy containers, we also ship them. We run self-managed Kubernetes clusters on AWS, and we manage the whole life cycle of Kubernetes clusters, nodes, and underlying infrastructures. We treat the node as cattle. We replace and patch the nodes on daily or weekly basis. We run Kafka inside our clusters. And if networking underlying infrastructure has some performance issue or some latency, it impacts Kafka throughput definitely, especially because we're mirroring the topics between clusters, and this replicating needs really good network underlying infrastructure. Then we decided 2 years ago, migrate to Cilium. And we evaluated multiple solutions at that time. The solution that has less complexities for troubleshooting and better visibility and networking, and reliable solution for us and fit somehow to our infrastructures. And we did this migration not in one run. With multi-step migration, we did with near zero downtime. And if you are interested, at the end of the slides is the link to that, how we did this migration. We enhanced Hubble metrics by using the context options and adding new labels into Hubble metrics to have and populate these labels with Kubernetes metadata, like service name or pod name or identity or something like that. And based on that, we created a custom dashboard, and it does help us really good to understand the networking. And Hubble CLI, by interacting with Hubble Relay API gives us really good cluster level networking visibility and service-to-service communications, and with really good number of filtering. You can do lots actually. And of course Cilium CLI as well, by interacting with Cilium agent API gives you really good network visibility on each node or eBPF state of that node or everything. Made us analysis and network interruptions easier. That means we don't need anymore install a sniffing plugin for kubectl or SSH to node and do some execute some capturing and to check our networking. We have granular policy enforcement and enhanced visibility into layer 7 traffic. After we enable the Cilium network policy, that means both of them in one place. That is really good for us. And we don't need any application level firewall for it, and Cilium network policy do everything for us. Some months ago, we identified some limitation for our sidecar-based service mesh. From one side, service mesh vendor announced that they want to change their rollout and release strategy, which didn't fit to our requirements. From other side, we couldn't have full visibility into layer 7 traffic, as the traffic leaves the pod namespace that was already encrypted by sidecar, and if the Envoy proxy wants to handle the layer 7, Hubble could not somehow have visibility to HTTP data. And we have investigated at that time a lot, and we checked Cilium. Cilium has really good security feature to replace it completely what we had before, and it could simplify our operational complexities. For example, we enabled the transparent encryption for whole encryption from pod to pod, node to node, only with enabling one flag in our Helm chart, and everything happens automatically managed. You don't need to rotate the key manually, and everything happens under the hood. And then we achieved the better application and resilience and better observability. And we simplified our infrastructure and reducing overhead by leveraging eBPF. And for service load balancing, we used before kubeproxy, which based on the IP tables. We replace it with eBPF, and to have better performance and avoid the inefficiencies of IP tables, especially for a larger scale of Kubernetes clusters. If you have a lot of thousand services and use IP table, then this latency is noticeable. We enable eBPF house routing for optimized packet processing and bypass the host network stack. After the packets leaves the pod namespace, the eBPF program intercepts this packet and it bypass the host network stack and routing and reaches at the end to physical interface directly. And from egress and ingress traffic, you have everywhere eBPF to move forward your data to each interfaces. And you have faster namespace switching at the end. And in conjunction with eBPF host routing, we want to further optimize our networking infrastructure and replace the WETH device with Netkit pair for achieving host level throughput for our container namespace and reducing the latency by using the layer 3 routing instead of layer 2 and ARP lookup and such a thing. And for some of our applications, they should communicate across the clusters. Currently, we have traditional API gateway or something. We are looking for the solution for that. But we check that cluster service mesh. It's a good choice for us. Using eBPF again for having the secure pod-to-pod communication across the multiple clusters. That is our future plan. If you are interested about how we did migration to Cilium, you can see the link here. And recently we did Cilium CNCF case study, as you can check as well what happened after the Cilium migration and what changed for us. Yeah, thank you very much. Thanks.
Hi, my name is Bowei, and I'll be talking about Cilium scalability improvements. This is primarily work from my colleague, George, who unfortunately couldn't make it here today. So first, some background on GK's data plane. So what is GK's data plane? So some of you might have heard data plane v2, but really it's an implementation of Kubernetes networking with Cilium at its core. So why do we use Cilium? So Cilium provides the core Kubernetes networking features in GKE, from pod-pod connectivity to security and observability. And we find it's highly extensible in a flexible data plane due to the use of eBPF. Where do we see Cilium evolving? So one of the key areas where we see Cilium evolving is in the area of scale. So we're seeing that our customers want to run bigger clusters, more pods, more services, network policies. You know, quite a few years ago, we saw a cluster with like 1,000 nodes. We saw that it was, wow, this is such an achievement, but the number just keeps growing. So concretely, getting to the scale will touch on a number of key Cilium features, so such as scalable distribution of pod metadata using Cilium endpoint slices, enhancing the scalability of network policies and identities with things like operator-managed identities, scaling Hubble flow monitoring, and handling services with a large number of backends. So the biggest cluster that we have deployed to date on GKE has 65,000 nodes. I'm pretty sure not everyone has that use case, but it's an interesting data point to have. So this means Cilium agent on 65,000 nodes, all programming the networking data plane, contacting the Kubernetes API server. So how did we do this? We had to enable a subset of features. We found that not all Cilium features today are able to scale to that. And of course, we had to make the API server super high scale. So one particular challenge that we had to meet in this case was that we saw a very high pod churn rate of up to 500 pods sort of lifecycle changes per second. And this is sort of very interesting because like, how do you handle that in the control plane? So currently, we achieve this by restricting it to a subset of Cilium features. So we use Cilium IPAM, pod-to-pod connectivity, Kubernetes service, and Hubble with basic observability. Ideally, we would like to make this high-scale feature as feature-complete as possible, to the extent that's possible. So kind of looking at scalability dimensions that we hit, the critical ones were, of course, the size of the cluster in terms of number of nodes. And what we noticed in this case is once you get up there in terms of numbers, it's really the pod churn rate that you are limited by. And the key bottleneck here is actually the Kubernetes control plane. All the control plane operations with respect to the lifecycle of nodes and pod churn contribute to kind of restrict the kind of scalability you can get. And sort of getting this control plane and Cilium's control plane to this scale will be a very interesting design challenge. So a couple of proposals, I think, for those of you who sort of are in the community to watch for, is there's this notion that is being discussed in the community about configuration profiles. So we realize that 65K nodes is not necessarily everyone's cup of tea, but there are a few users who have this as a critical use case. What Cilium configuration profiles tries to capture is that, okay, let's capture this high-scale networking profile. Let's figure out, what features make sense and build towards that, make sure that's tested, make sure these features work really well together. I'm pretty sure there's some other profiles, for example, some on-prem profile with complex networking. That would be another use case where we make sure that all those Cilium features that you need for that profile are really being developed for. You can think of it kind of like a Cilium persona in some sense. One of the first profiles that's being contributed is this high-scale basic networking profile. And I think one of the things is, this big audience is go look at that. Does that make sense for you? Can you think of other profiles that you fit into? That would be nice to know. And finally, there's some work, these are mostly proposals at this time, on how to do network policies at mega cluster scale, which is a very interesting challenge. And with that,
all right. Hi, I'm Anna. I'm a software engineer at Isovalent, and I work mainly on Tetragon, which is a separate project under Cilium umbrella that extends Cilium observability and security capabilities with generic eBPF-based policies. So here I am to give updates about the Tetragon project, but first I would like to give updates about another project under Cilium umbrella. eBPF-Go. eBPF-Go is a Go library for loading eBPF programs. It is used by Cilium CNI, by Tetragon, by many other projects in the cloud-native ecosystem. And there is one new feature in this library, Windows support. So eBPF, as you probably know, is Linux kernel technology, and it's Linux specific, but eBPF for Windows does exist too. It is not production ready yet. To use eBPF for Windows, you need to disable Windows security features, which you probably don't want to do in production, but we are working with Microsoft to make eBPF for Windows GA and production ready. eBPF-Go library has initial support for Windows, so we can start building cloud-native tools for using eBPF for Windows using Go. And why am I talking about it? I'm talking about it because Tetragon Windows support is also coming. So we are planning to release initial Tetragon Windows support in the June 1.5 release. This initial support will include process create and process exit tracing. So the core feature of Tetragon events for process execution and process create and process exit. From other features, eBPF CPU overhead. So this is quite exciting. One of the perks of using eBPF is that we can provide security, visibility, and enforcement with minimal overhead. And we really like talking about it, how Tetragon provides security with minimal overhead. But when people ask us, what exactly is this overhead, we are often like, we need to benchmark it. We do benchmarks. in which we compare system without Tetragon. We install Tetragon, install policies, measure CPU memory overhead by calculating the difference between system without Tetragon and system with Tetragon. So we do such benchmarks. We publish results. You can find results in the Tetragon blog. But these are benchmarks run in one particular environment, which may or may not match your production environment and behavior of Tetragon in your specific case. So we need better measurement of the overhead. And we introduced it in the recent Tetragon release. So now Tetragon has built-in measurement of both CPU and memory overhead down to individual BPF programs, individual BPF maps. So the Tetra CLI, the CLI for debugging managing Tetragon, exposes this debug command where you can see exactly what BPF programs are loaded by Tetragon and how many times they were executed, how much CPU they took. The programs are structured in file system in a hierarchy, so you can also understand exactly how they map to Tetragon policies you have installed. This information is also exposed via Prometheus metrics, so you can easily graph the CPU information in Grafana, for example, or alert if it's too high. And similarly for memory. We also measure eBPF memory overhead, which it's mainly the main contributor to memory usage is BPF maps that sometimes can grow quite large. So Tetra debug command also can list all the BPF maps loaded by Tetragon, used by Tetragon, how much memory they use. And we also expose Prometheus metrics that link this information to the Tetragon policies loaded. From other new features, there are a few new features that will be released in the that were released recently in the latest release. One of them is more advanced policy language. So Tetragon has a very generic and low-level policy language that allows you to hook to literally any point in the Linux kernel and extract any arguments processed by the kernel function. And this language is got even more advanced so that now you can extract fields from inside a kernel structure, for example, from inside a file structure that is processed by a kernel file operation. Another new feature is a configurable policy mode. So Tetragon has two modes, observability, enforcement. By default, you get events, you observe what is going on, but you can also switch a policy to an enforcement mode. So typically what you would do, you would apply an observability policy, see if there is anything suspicious, and after you audit the events, then you can switch it to the enforcement mode. This is also available via Tetra CLI if you don't want to manage policies via a Kubernetes API or you are running outside of Kubernetes. And the last of feature highlights is cell filters. Common expression language is a language that allows you to write arbitrary expressions that are filtering JSON, Tetragon JSON events, and you can write such filters where you are exporting Tetragon events to a log file or when you are querying them via Tetra CLI. So this allows you to write very advanced rules that, for example, detect a particular CVE exploit. Or here on the slide, I have an example rule that detects an attacker searching for AWS credential potentially. All right, so this is it from new feature highlights. Now, I would encourage you to try Tetragon if you haven't already. And if you are using Tetragon, then join us in the community meeting. We have a monthly community meeting on the second Monday of every month at 6 p.m. Europe time. We have very diverse community. The community members range from students who want to learn something about eBPF to employees of large corporations that have very advanced and very specialized security requirements, and everybody in between. So if you are interested in Tetragon, please join community meeting and stay in touch with us on Slack. So in Cilium, in eBPF Slack, there is Tetragon channel where all of the Tetragon developers hang out. And this is it from me. With that, I will hand over to Bill again.
Thanks, Anna. So now I'm going to give you the last updates from the Cilium community. So the first one, Linux Foundation. If all this has excited you, Linux Foundation now has a Cilium Certified Associate exam. This is to show your knowledge to the community and to future employers or your employer about your knowledge of Cilium. It's also part of the newly announced Golden Cubestronaut. So this is a great way to jump into the ecosystem and show what you know about the project. Cilium also released its annual report. We called it the year of Kubernetes networking, talking about how Cilium has really taken over the networking stack from layer 2 to layer 7 and really providing you a complete solution for whatever your needs are in cloud native networking. It's a great summary of everything that happened in the last year in the project, and I'd recommend that you check it out. In terms of what's happened here so far at the week, my week and for a bunch of the other Cilium developers actually started on Monday with the Cilium Developer Summit. This is the third time we've had that. We bring all the developers around the world into one room to discuss the future of the project. We have them before each KubeCon, so if you're interested in getting more involved in the project or talking about a feature, this is a great way to do it. We'll have it in NA too. Cilium is now kind of trying to increase the scalability of not only the project, but also the community too. So Cilium now has SIGs, or special interest groups. The first one is actually SIG Scalability too. So if you're interested in that one, come to this one. Or if you're interested in a different part of the project, feel free to come by and suggest a different SIG that you think the project should have. Cilium is an open source project under the CNCF. We're always looking for new contributors, new contributions. There's many ways to get involved in the project where you can start in the Cilium community repo to learn about how you do it for both code and non-code contributions. And one very easy way to get involved and to help out the community is to do a case study with the CNCF. We have 3 new ones from DB Schenker, as we talked about, from Queen Cloud, and from Sys11. But if your company is using Cilium in production, and I saw half the hands in this room go up, please come talk to me. We'd love to have a story about how you're using Cilium and benefiting from it, so you can tell your story to all the other people and help other people learn about the benefits of Cilium. And then the last thing to echo once again, we're always looking for more contributors. We have developer meetings every week on Wednesday in the afternoon European time or in the morning in the US. There's also a monthly APAC-friendly meeting, and Tetragon also has a weekly meeting too. Please stop by and tell us about how you're using the project or what you'd like to see next. So with that, thank you for coming, and I think we have maybe 1 minute for one question.